In this video, we're going to look at the learning target. I can solve a system of equations, including a line, parabola, and circle by using elimination. Now, when we use elimination as our method for solving a system, what we're going to do is we are going to add or subtract the two equations from one another to eliminate one of the variables. So if I look at number one, I have y equals 9x squared plus 5x plus 2. And I have y equals 7x squared minus 8x minus 19. And I want to find the ordered pair, the x and y value that makes both of these equations true. So to do this using elimination, I want to eliminate one of the variables. And I notice that I can eliminate the y variable if I subtract the two equations from one another, right? If I take y minus y, well, y minus y cancels and I'm left with 0 equals 9x squared minus 7x squared. Well, that gives me 2x squared. If I take 5x minus a negative 8x, well, this is where you got to be a little careful. If you subtract the negative, that's really like adding, right? So 5x plus 8x is really 13x. And then 2 minus a negative 19, once again, if we subtract a negative, that's really adding. So 2 plus 19 is 21. Okay, so in this case, when we use elimination, we can either subtract or add. In this case, we subtracted to eliminate the y's. And you'll notice now I don't have any y's left in the equation. This allows me then to factor and solve for x. So to do that, I ask myself what times what gives me the first term. Well, that's going to be 2x and x. I then think about what times what gives me the last term. Well, to get 21 is 1 and 21. It's also 3 and 7. I need to pick the pair and order them so that I can get a 13x in the middle. So I'm going to put the 3 in the last spot, so that gives me 6x. I'm going to put the 7 on the inside, so that gives me 7x. 6x plus 7x is 13x. Okay, so I get this. And then I solve this by setting both factors equal to 0. So I get 2x plus 7 equals 0, or x plus 3 equals 0. That gives me x equals negative 3. And this one gives me x equals negative 7 halves, which is x equals negative 3.5. Now, I almost circled that. I almost made a cardinal mistake. Remember, these x values are not your solutions. The ordered pairs are. We still need to find the y coordinate. We need to take these two x values and we need to plug them back into the equation. So to find the y value here, well, y equals 7 times x squared. Well, x squared is negative 3.5, so negative 3.5 squared minus 8 times negative 3.5 minus 19. Okay, I have to plug that in. So if you take a calculator here, I have a scientific calculator. I'm just going to type all of this in. So 7 times negative 3.5 squared minus 8 times negative 3.5. Then I'm minusing 19 from that. I get 94.75. Okay, so my ordered pair, my first solution would be negative 3.5, comma 94.75. Okay, that is one solution of the system. To find the other solution, it's the same thing. I just plug negative 3 into the equation. So I'm going to plug negative 3. And you can plug it into either equation. So maybe this time I choose the top equation, which says y equals 9 times negative 3 squared plus 5 times negative 3 plus 2. Well, negative 3 squared is 9. 9 times 9 is 81. 5 times negative 3 is negative 15. And then I'm adding 2 to that. So then if I just combine those three numbers, 81 minus 15 plus 2, I get 68. Okay, so y equals 68. So my ordered pair here will be x is negative 3, y is 68. That also is a solution. Okay, and remember, solutions just mean that if you were to plug this x and y into either one of these functions, they will make both equations true. Okay, let's go ahead then and look at one last example here. So in number 2, I have x squared minus 7x plus 11 equals y minus 1, and I have negative x plus y equals negative 4. Now, once again, I want to add or subtract the equations to eliminate one of the variables. You'll notice, though, nothing's really lined up nicely like it was in number one. Number one, the y's were lined up over top of each other, and I could just subtract the two equations. Here, I don't have that. But what I can do is I can rearrange these so that I do have it set up that way. So to do that, I'm going to keep the first equation the same. So I'm going to leave it as x squared minus 7x plus 11 equals y minus 1. But then I'm going to flip this guy and kind of do a little rearranging. So I'm going to move negative 4 over to the left side. And then negative 4 equals a positive y and a negative x. Okay, so this is really the same thing as this, right? Negative 4 equals a positive y, negative x, negative x. Okay, so I'm just rearranging the bottom guy. And the reason why I'm doing that is I want to get the y's lined up over top of one another. That way I can subtract once again to eliminate them. Notice that y minus y will cancel them. Okay, that's the goal. So if I do this, I need to subtract every term on both sides of the equation. So if I take x squared minus, I don't have anything down here, so the x squared just kind of falls down. I keep it as x squared. Negative 7x minus, well, I'm not subtracting any x terms, so that's just going to fall down as well. I'll get negative 7x. If I take 11 minus negative 4, well, once again, if you subtract a negative, that's really adding. So 11 plus 4 is 15. And then if I take negative 1 minus, I'm not subtracting any like terms. So the negative 1 will just fall down. And then if I take nothing up here minus a negative x, if I subtract a negative x from nothing, that's really adding x again, right? Subtracting a negative. If you take 0 plus x, well, you just get a positive x. I notice that I have an x squared and x, so I need to get everything on one side. So I'm going to add 1 and subtract x. Move both terms to the other side, which gives me 0 equals x squared minus 8x plus 16. Once I have the standard form equation equal to 0, I can solve this by factoring. Okay, x times x gives me x squared. If I think about numbers that multiply to 16, well, that's 1 and 16. It's 2 and 8 and 4 and 4. I need to get a negative 8 in the middle, so I'm going to use negative 4 and negative 4. I set my factors equal to 0, and I solve them. So I'm going to get x equals 4 and x equals 4. Now remember, these aren't our full solutions yet. They're just our x values. We need to find our y values. So to do that, I plug 4 back into one of my two equations. I notice the bottom one's more simple, so I'm going to use the simpler equation. I'm going to plug 4 into that. So if I plug 4 into this, I get negative 4 plus y equals negative 4. If I add 4 to both sides, you'll see that you get y equals 0. So I'm going to get 4, 0, and I actually get that same point if I plug in the other 4, right? Oh, sorry, I didn't know I was getting cut off. So if I plug 4 into the equation up here, you end up with negative 4 plus y equals negative 4. Add 4 to both sides, you get y equals 0. And then once again, if I plug the other 4 in, I get the same thing. So my solution here is the point 4, 0.